Okay, right now we will go into two-level factorial design using the data that already has been given. So the data has 4 factors. So we will be going to use 2 to the power of 4 factorial because of 4 factors. So we choose 2 to the power of 4 and we click continue. So this is the 4 factor that we get: the temperature, pH, sugar concentration and inoculum size. So we will put their low actual and high actual, which is 25, 35, 4.5, 6.5, 50, 100 and 2 to 10, and next continue. So the responses is only 1, continue. So this is the standard run, which is 16 run. So we must fill the response with the data which has already been given. So for the first one, we can look at the factor and we put the appropriate data. So for this one, we have 34.5, 50 and 2. So we will put 87, which is the closest to this data. And same for the second one. We have 250, 4.5 and 25. So we will also put 87 because this is the closest data. And same goes until the end of the response. So that's all from me. Thank you very much.
First, you open the software and then you go to new design and then you choose the packet environment, and then we input the factor, which is the temperature, pH, sugar concentration, and the inoculum size. For the unit, for temperature, which is Celsius, degree Celsius. For pH, it doesn't have. For sugar concentration, which is gram per liter, and for inoculum size, which is percentage. And then we input the data for the low and high for the 4 factors there. Then we continue. Then we get this table data. Then we go for summary here. We look at the graph console, the data here. We go for inflation. We go back to the design or actual design. We input the data for response. Then we go for analyze. We go to the effect. And then we choose all of the graph there. Then we go to ANOVA. So for ANOVA, we got R square, which is equal to 1. We look for diagnostic here, and then we look for model graph here. Then we go for optimization for numerical. We go for the solution here, and then the graph. Then we look at the graphical. For prediction, and then we go back to the design. And that's all from me. Thank you.
This is a response surface methodology RSM for the optimization of ethanol production. And for this part, I will explain about central composite design (CCD). And in the central composite design, it has a numeric factors, which is the optimized factor for this experiment. It has a 4 type of factor, and for the name part, we include the name for each factor and the units for each factor. Based on the experiment that we conduct. And if you can see, it has a negative one level and positive one level. And in this part, negative one is about a minimum range for this optimize, and the positive one is a maximum range. For the negative alpha and positive alpha is already calculated based on the range that we include. At the below of it, it has a 30 run, which means the number of run. And we go to this is a list of response involved in this optimization. And for this experiment, we only use one response. And then this is a standard run, including 30 run for all of the factor 1, factor 2, factor 3 and factor 4 is actual values. And for the response, we insert experimental data for all the standard. And then we go to the response analysis, including fit summary, model, ANOVA, diagnostic and model graph. For the fit summary, it is a summary of the top, sum of square, leg of fit and R square. And then we go to the model, and therefore ANOVA as a top, ANOVA, R square and coefficient and equations. So you can see it was all of the data. So diagnostic, it has a graph, normal plot, residual versus predicted, residual versus run, predicted versus actual, box cost plot for power transform, residual vs temperature. And for the model graph, it has a response for temperature versus pH. Include the factors sugar concentration and inoculum size. And that's all from me. Thank you.
Alright, for board bacon surface, first we click the surface and then board bacon. Since our numeric factor is 4, which is temperature, pH, sugar concentration and inoculum size. So we put the value for name unit, the lowest and the highest. And then we have response, which is 1. For the ethanol yield, which is unit, is percentage. And then for the next part, we must enter the value for the response, which is from the table. You can follow as I do, which is copy and paste the value into the box and paste. So this is the response one for the ethanol yield percentage. Then we can start to analyze the data. So this is summary. As we can see the study type of the response surface and the RAS, which is 29, the blocks, and initial design is board bacon and design model is quadratic. We also can see the standard deviation for each factor. And then we can see the graph, which is the x-axis is temperature and the y-axis is yield. Then for the model is we use quadratic. For the result, we can see the value for the rate of heat, degree
of freedom for evaluation, which is layout fit 10, period error is 4, correction total is 28, and residual is 14. So here we also can see the percentage of the standard deviation of each numerical factor. And then next we can see the graph. Here we can see the minimum, standard, mean, and maximum. And for this one, we can see the 3D surface. This is sugar concentration 3D surface, and this one is in column size 3D surface. And for this one, we can see the contour, which is the X1 is temperature and X2 is pH. The actual factor for sugar concentration is 75, and for the column, in column is 2.68. Here in the fit summary, we can see the mean value, F value, P value. And layout fit test, you also can each of the value, sum of square, df, mean square, F value, P value. And for this one model, the selection is manual and the process order we choose for quadratic. And here we can see the ANOVA. For ANOVA, we can see the value for the F value, P value, mean, and square. Also can see the value for layout fit, P error, and for the R square, standard deviation, mean, CV, percentage. And also we can see the finite question in terms of code factor. Also the finite question in terms of actual factor. And for the diagnostic part, we can see the normal plot of residual. And then we can see for the next part is model graph. This in contour form. So we can see the eternal yield for the contour, which is the x-axis is temperature and y-axis is pH. And for this one is for 3D surface of the in column size. And this one is for the sugar concentration. And this one is default, which is for the temperature and pH. The actual factor for this one is sugar concentration 75, and for in column is 6. And for this one, for the format of the cube. And this for the in column. And I think that's all for the box pattern.